In this video, I'm going to look at constant acceleration in 2 and 3 dimensions. If you're looking for variable acceleration, which uses calculus, just click the link below. I'm going to look at an example here in 1, 2 and 3D so that you can see how they compare. The particle starts from the origin and has initial velocity u and acceleration a. So I've laid out 3 scenarios here. The first one, initial velocity u is equal to 3. In here I've put u equals 3i minus 2j, so I've just added a second dimension here. And in the third one I've added to those two to give a third dimension 1k. For the acceleration, a equals 1 in one dimension, 1i plus 3j in 2 dimensions, and 1i plus 3j plus 0k in 3 dimensions. We don't bother writing the k. So vectors are often shown in this IJK format because it's a bit fiddly to type column vectors in documents. However, it's often easier to work with column vectors when you're doing a problem. So I'm going to write the column vector format here. So u equals, and then 3 in the first row, negative 2 in the second row. A equals 1 and 3. Here, u equals 3, negative 2 and 1. And a equals 1, 3 and 0. Notice I must put the 0 in to show that it's in 3 dimensions. As usual, I'm going to write down the key values from the question in a list format so that they're easier to read. So here I've already written the u and the a, but looking back at the question, we've got to find the velocity and position after 4 seconds. So t, time, equals 4 seconds. And that's just a scalar quantity here, the same in each scenario. And we've got to find the velocity first, so velocity v, we don't know, so I'll just call it v. So we have v, u, a and t, so the obvious choice here is v equals u plus at. In one dimension, it's very simple. V equals u plus a t, 3 plus 4, which is 7 meters per second. In the second scenario, v equals, and now I'm going to use the column vector format, u plus a multiplied by t, and as there are 2 rows in my columns in the equation, there'll be 2 rows in the final answer. So I just treat each row separately, remembering that if I multiply a vector by a scalar, just multiply each row by that scalar, so 4 and 12. So treating each row separately, 3 plus 4 is 7. And negative 2 plus 12 is 10. So 10 meters per second. In 3 dimensions, 3, negative 2 and 1 for u, plus a t. And I've just used the same values for the first 2 dimensions, so there'll be 7 and 10 again. The third dimension I've added 1 plus 0 multiplied by 4, which is 0, so that's just 1 meter per second. The next part is to find the position. So in order to do that, I need the displacement, which is s equals ut plus half at squared. Now the full formula here for the position would be r, which is what we use to indicate the position, as distinct from the displacement, equals r of 0, the initial position, i.e. r at time 0, plus ut plus half at squared. So that's the usual displacement formula. Now in this case, the particle is starting from the origin, so its initial position is 0. And I'm going to show you later what would happen if that was not the case. But for now, I'm just going to use the shorter formula, leaving this out because it's 0. So r equals ut plus half at squared. In the first case, 3 times 4 plus half a, which is 1, and t squared, which gives us 20 meters from its original starting point. For the second scenario, r equals ut plus half a t squared. So working out each row independently, 3 times 4 is 12 plus a half times 1 times 16, which gives us 20. And then negative 2 times 4 plus a half times 3 times 4 squared, which gives us 16. So that means it's been, its new position is 20 in the I direction and 16 in the J direction from the origin. For the third scenario, it's exactly the same principle. R equals 3, negative 2, 1. So u multiplied by t plus a half a t squared. And again, the position in the I and J direction, as I've used the same values, will be the same as before. And now I've got 1 multiplied by 4, which is 4, and then a half multiplied by 0 times 4 squared. So my answer is just 4 for that. And that's meters. Now if the particle, say for the first scenario here, had initially started 5 meters from the origin, the difference between these two formulae is that we would have just had these terms plus an extra 5, and that would have given us 25 instead of 20. If I look at the 2D version, again very similar. I have these two terms exactly the same, with the addition of it started 5i plus 2j from the origin. Adding those in, I add 5 to the I component and 4 to the j component. Sorry, 2 to the j component. And that's the only difference between the two.